Hello everyone, hope everyone is fine and doing good. So what is update? Well, update is in this video I'm just going to discuss the solution of questions of quiz number 3. So let's get started. Question number 1 of quiz number 3 is the position vector of an object is represented by this position vector, which is 2t square I cap plus 5j cap. The first part of this question, what is distance and displacement of object at time t equal to 5 seconds. Okay, so to know about distance and displacement, I should know what are the positions of the object at different instant of time. Namely, here I am interested in knowing the position of an object at time t equal to 0 and time t equal to 5 seconds. Okay, so first let's isolate x and y coordinate. Here we already know that the coefficient of I and j cap represent the position of object along x and y coordinate. Okay, so let's isolate them. So x is 2t square and y is 5. Okay, now at time t equal to 0, x coordinate is 0 and y coordinate is 5. Okay, now at time t equal to 0, I can say the position vector r1 is nothing but that is 5j cap. Okay, because x coordinate is 0 over here. Okay, now let's calculate at time t equal to 5 second. So x coordinate is written as 50, y coordinate that is same 5. Okay, so we can see whatever be the instant of time, the y coordinate is not going to change, right? So what does it mean? It simply means that the particle will take a straight line path. I will show you it how. Now let's write down the position vector corresponding to the final position, that is r2, and it is 50 times of I cap plus 5j. Okay, so now let's draw these two position vector on Cartesian coordinate system. At time t equal to 0, the position vector r1 is 5j. So that's mean this is this at time t equal to 0. So this is what this is r1. Okay, this is the initial position vector, and r2 will be somewhere here. This is 50, 5. Okay, so if I join this point to the origin, it will be what? It will be the position vector r2. Okay, now if I join initial position to the final position, it will be what? It will be the displacement vector, and displacement vector is written as r2 minus r1. We already know it, right? So let's plug in the value, the expression of r2 and r1 over here. So r2 is how much? This is 50 I cap plus 5j minus r1. r1 is what? r1 is 5j. So from here I can say I will be getting only 50 I cap. This is what? This is the displacement vector. Now it is obvious, as we already know that whatever be the time over here, the y coordinate is not going to change, right? So what does it mean? The particle has to travel along a straight line, right? And that straight line is along the x-axis. Only then the y coordinate doesn't change, right? So our displacement vector give the same information. Okay, so this is what the displacement vector. Now what is the magnitude of this? Magnitude is 50 meters, and since the particle is moving along a straight line, so the distance is also equal to 50 meter. Okay, so this is the solution of first part of this question. Now let's work out for the B part. Part B of question number 1 is, what is velocity at time t equal to 5 seconds. Basically, it is a question of finding the instantaneous velocity. And we already know that to find out the instantaneous velocity, we should take the derivative of the position vector. Okay, so let's write down it over again. It is 2t square I cap plus 5j, and if we take the derivative of this with respect to time t, then it will give me how much? It will give me 4t I cap plus 0 j cap. Okay, so this is what this is the velocity vector, instantaneous velocity vector, and from this expression it is clear that the instantaneous velocity vector is along the x direction, right? And it is obvious because the y coordinate is not going to change with respect to the time. So if I plug in the value of time t equal to 5 seconds over here, then it will give me instantaneous velocity vector is 4 into 5, that is 20 I cap. Okay, so the instantaneous velocity, or you can say that the velocity at time t equal to 5 seconds is along x-axis, right? And what is the magnitude of this? Magnitude is 20 meter per second. So this is the solution of B part. Now the C part is, what is average velocity? Now to find out the average velocity, I will apply the formula. V average is equal to total displacement divided by total time, right? And the displacement can be written as vector r2 minus vector r1, and this is what, this is the time. Okay, so now plug in the expression of r2 and r1 over here. We can say r2 is this 50 I cap plus 5j minus r1. R1 is what? R1 is this, right? So let's plug in over here. So it will give me 10 I cap. Okay, so this is what the average velocity vector. And what is the magnitude of this? Magnitude is 10 meter per second. Okay, so here in this case, this is what, this is the average velocity, and we can notice the average velocity and instantaneous velocity, these two are different. Okay, now the D part is what is average acceleration. Okay, so for this, let's write down the position vector again. This is 2t square I cap plus 5j. If I take the derivative of this, then I will be getting instantaneous velocity vector. It is 4t I cap, and to find out the average acceleration, what should I need to do? I need to take the change in velocity, upon change in time, right? Now let's see what is this velocity vector at time t equal to 0. So we can say that at time t equal to 0, this velocity vector is 0, right? And at time t equal to 5 seconds, this velocity vector becomes 20 I cap. So what is the change? Change in velocity is what? 20 I cap minus 0. And what is the change in time? That is 5 seconds. So from here I will be getting average acceleration vector. It is 20 upon 5. So that is 4 I meter per second square. Okay. So this is what, this is the average acceleration vector. Now what is the magnitude of this? Magnitude is 4 meter per second square. Now from this expression you can notice that average acceleration is along the x-axis, right? So that's mean whatever be the instant of time, you will be getting the different velocities along x-axis at different instant of time. Okay, so that is because of presence of this acceleration over here. Okay, so this is the solution of D part of this question. Now take a look on the second question of quiz number 3. Number 2 of quiz number 3 is The position of a moving object along x-axis, it is represented by 2t square plus 5. The first part of this question is, what is the distance and displacement at time t equal to 10 second. So for this, let's calculate x at time t equal to 0 and time t equal to 10 second. So it is 5 meter and it is 205 meter. Okay. Now let's draw these 2 points on x-axis. This is time t equal to 0. This is what? X equal to 5 meter, and this is the position x equal to 205 at time t equal to 10 second. Now the distance between these 2 points is actually the distance traveled by the moving object. So this distance is equal to 205 minus 5, so it will give me 200 meter. Now since the object is moving along a straight line, so we can say displacement is also equal to distance and it is equal to 200 meters. So this is the solution of first part. Now let's see the solution of second part. In this we have to calculate speed and velocity at time t equal to 10 second. Now this is the question about calculating the instantaneous velocity, and we already know that to calculate the instantaneous velocity we take the derivative of position of the moving object, right? So let's do it. So v instantaneous is equal to dx over dt, and it comes out to be 4t. Just plug in the value of time t equal to 10 second over here, and we will be getting v instantaneous is equal to 40 meter per second. Now I just want to check whether the average velocity is equal to instantaneous velocity or not. So for this I will apply this formula, v average equal to displacement upon time. And what is the displacement? Displacement is equal to 200 meter divided by 10, so it will give me 20 meter per second. So what we are observing here, we are observing here that average velocity is not equal to the instantaneous velocity, right? So this is the solution of part B of this question. Now let's see the third part of this question. We have to find out average acceleration. Average acceleration is change in velocity upon change in time. Change in velocity can be written as v10 minus v0 divided by 10. Why this is 10? Because the time change is 10 second. What is v10? v10 is the velocity of the moving object at time t equal to 10 second, which is 40 meter per second, and v0 is 0. This is the velocity at time t equal to 0. If you plug in the value time t equal to 0 over here, then it will give you instantaneous velocity equal to 0. So on solving, I will be getting v average equal to 4 meter per second square, right? Now here I just want to verify whether the average acceleration is equal to instantaneous acceleration. So to calculate the instantaneous acceleration, I will change delta t such that this delta t is going to almost equal to 0. And if it is, then I can write down a instantaneous is equal to dv by dt. So this is what? This is the derivative of velocity vector, right? So if I plug in the value 40 over here, then it will give me v instantaneous is equal to 4 meter per second square. So this comes out to equal to average acceleration, right? Now the logic is, since it is the case of uniformly accelerated motion, so in this case I'm getting instantaneous acceleration is equal to the average acceleration, right? So this is the solution of question number 2 of quiz number 3. Now let's discuss the solution of question number 3. Question number 3 of quiz number 3 is the position of any object moving along x-axis. It is 2t square minus 10. The first part of this question is what is the distance and displacement of the object at time t equal to 10 seconds. So for this I should have the knowledge of position of the object at time t equal to 0 and time t equal to 10 seconds. So let's work out these two values. So x is equal to minus 10 meter and x equal to here, that comes out to be 190 meter. Now if I draw these 2 points along x axis, consider this is x equal to 0 and this is x equal to minus 10 meter at time t equal to 0. Now the point corresponding to time t equal to 10 second is 190 meter. Now here in this case we can say the distance between this point and this point is actually the distance traveled by the particle. Okay, so what is this distance? Let's work out this. So this distance is equal to 190 minus 10, so it will give me 200 meter. And since the object is moving along one dimension or along a straight line, so the displacement is also equal to the distance. Now the B part of this question is, what is speed and velocity at time t equal to 10 second. For this I need to take the derivative of this equation. So let's work out this. So dx over dt equal to v, and it will give me how much? It will give me 40. Now if I plug in the value of time t equal to 10, then it will give me 40 meter per second. Right. So this is the velocity at time t equal to 10 second, and the speed is also equal to the velocity because the object is moving along one dimension. Okay. So this is the B part. Now if I just want to verify that whether the instantaneous velocity and average velocity are equal, so for this we have to work out for average velocity. So V average is nothing but this is displacement upon time. And what is the displacement in this case? Displacement is equal to 200 meter. So if I plug in the value over here and time is 10, so it comes out to be 20 meter per second. So basically we can see here instantaneous velocity and average velocity comes out to be different from each other, right? Now let's see the C part of this question. We have to find out the average acceleration over here. So what is the average acceleration? Average acceleration is change in velocity upon change in time. What is the change in velocity? That is v10 minus v0 divided by what is delta t? It is 10 seconds. Now v10 is equal to what? v10 is 40 meter per second and v0 is 0, right? Why it is 0? Because if you put time t equal to 0 over here in this expression, that will give you the 0 velocity, right? And finally A average is comes out to be 4 meter per second square. Okay, so this is what this is the average acceleration. Now I just want to check whether the instantaneous acceleration and average acceleration are equal to each other. Okay, so for this what should I do? I should change this delta t such that this delta t is going to be almost equal to 0, right? So for this, if I do this, then it can be written as dv by dt, and this average acceleration turns into instantaneous acceleration, right? And what is this? We know that this is the derivative of velocity with respect to time. Now the expression of v is this for t, and if I plug in the value of v over here, then you will be getting what? You will be getting that is equal to 4 meter per second square, right? So this is what this is the instantaneous acceleration, and we can see that average acceleration and instantaneous acceleration both are equal. Why? Because this is the case of the constant acceleration. So the logic is, if the object is moving with constant acceleration, then instantaneous acceleration is always equal to the average acceleration. So this was the solution of quiz number 3. Now at last of this video, I just want to discuss the concept of U-turn. The concept of U-turn implies that the moving object wants to change its direction of motion, and for this velocity of the moving object that should be 0 at certain instant of time other than time t equal to 0. and if it is, then definitely the particle is going to change its direction of motion. So for this I just want you to leave with a question. In quiz number 3 we discussed two questions, x equal to 2t square plus 5, and the last question was x equal to 2t square minus 10. Now what I want to do here, I just want to modify this question. Suppose the question like this, x equal to 2t square minus 12t. So basically what I have done over here, I have just included one more coefficient of time parameter, right? Now you will see the game is going to overall change. Basically what I want to do, I just want to calculate the distance and displacement at time t equal to 10 second, and the B part of this question is I want to find out speed and velocity at time t equal to 10 second. Now in order to solve this question, I'm just giving you some steps. Step number 1, find time at which velocity of the object is going to be 0. Step number 2, find x at time t naught. Step number 3, find x at time t. Step number 4 is calculate distance and displacement. Okay, so these are some steps which you need to follow while doing the solution of this question. So that's all for today, and in the next video I will discuss the concept of U-turn in detail, and I will discuss also the solution of this question. So that's all for today. So till then, stay connected and keep watching for further updates.